What if the third interstellar visitor ever discovered was not a comet, but a billion-year-old alien messenger? In the summer of 2025, a faint object designated 3IATLAS streaked into our solar system, and a controversial hypothesis immediately captured the world's attention. This was no ordinary rock. The idea of advanced alien technology made global headlines, but NASA quickly stepped in with a powerful, evidence-based response that settled the debate. So what did they find? Let's explore this together. The Atlas discovery in Chile. So, how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3IATLAS began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1. A definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3IATLAS, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. Here's where the story takes a sharp turn into speculative territory, thanks to a bold proposal from Harvard astronomer Avi Loeb. While most scientists saw a fascinating natural object, Loeb, known for his controversial work on Oumuamua, offered a different interpretation. In a scientific paper posted to the ArXiv preprint server, Loeb pointed to the object's early lack of a visible coma and its trajectory. He suggested that if the comet continued to show no outgassing, or if its path deviated from a purely gravitational path without a visible tail to explain the push, it could be evidence of something artificial. He even raised the hypothetical possibility of malign intent, though he stressed this was an intellectual exercise meant to keep science open to radical possibilities. His argument, similar to the one he made for Oumuamua, hinged on the idea that any non-gravitational acceleration without a visible coma required a novel explanation. He proposed that a solar sail, a thin, lightweight craft pushed by the pressure of sunlight itself, was one such possibility that science should not be afraid to consider, however unlikely it might seem at first. The physics of radiation pressure are well understood, but for it to be effective, an object must have a huge surface area and an extremely low mass, characteristics not found in natural bodies. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi Loeb's hypothesis for 3IATLAS was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea, while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. With the debate raging, NASA and its international partners marshaled their most powerful instruments. This wasn't a casual glance, it was a coordinated multi-platform investigation led by Tom Statler, NASA's lead scientist for small bodies. The agency dedicated priority time on the James Webb Space Telescope, using its near-infrared spectrograph or NIRSpec to perform detailed chemical analysis of the gases in its coma. Simultaneously, the Hubble Space Telescope's Wide Field Camera 3 was used for high-resolution imaging to search for any faint dust or fragmentation events with its superior resolving power in visible and ultraviolet light. On the ground, a network of observatories, including the twin 10-meter mirrors of the Keck Observatory in Hawaii, began a long-term monitoring campaign to track its brightness and trajectory with pinpoint accuracy. The goal was to leave no stone unturned, to precisely measure its path to within a few milliseconds, to analyze its chemical composition, and to study its light curve for clues about its shape and rotation. This multi-wavelength, multi-observatory approach is the gold standard in modern astronomy for characterizing a novel object. Comet behavior confirmed. So what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3IATLAS mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3IATLAS started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet, reacting to the Sun's energy. Its initial lack of a tail was simply because it was too far from the Sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. But confirming it was a comet was just the beginning. The real prize was in its chemistry. A team led by Dr. Anjali Sharma, a planetary scientist at NASA's Goddard Space Flight Center, used the James Webb Space Telescope spectrographs to break down the faint light from the coma into its chemical fingerprints. The analysis revealed familiar substances like water ice and carbon dioxide, but with a major surprise, 3IATLAS had an unusually high ratio of carbon dioxide to water, measured at nearly 35%. This vital clue suggested the comet must have formed in an extremely cold region of its home star system, far out in its protoplanetary disk where carbon dioxide could freeze out in large quantities. Furthermore, analysis of the dust grains showed a polarization signature with negative branching at a phase angle of 22 degrees, suggesting a surface composed of very fine, porous, fluffy dust grains, a sign of a very pristine, unaltered body. This fluffiness implies the grains have not been heavily processed by heat or collisions, making them a near-perfect sample of their native environment. This chemical snapshot provides invaluable data for models of planetary formation in other star systems. Trajectory and safety assessment. With all the talk of alien technology and, possible malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. So the whole 3IATLAS controversy really boils down to a single fundamental question in science. Is an anomaly evidence of something artificial, or is it a sign of a natural process we haven't encountered before? Science almost always bets on the latter. Our own solar system is filled with comets that behave in bizarre ways. Take Comet 29P Schwarzmann-Wachmann, which can increase in brightness by over 15 magnitudes, a factor of 1,000,000, in just a few hours due to cryovolcanic eruptions. Another example was Comet C 2019 Y4, or ATLAS, a different comet which unexpectedly disintegrated into multiple pieces as it approached the Sun, showing how fragile these icy bodies can be. The point NASA scientists made is that unusual traits are not automatic evidence of engineering. They're part of the normal, messy, and fascinating physics of icy bodies. These anomalies are not problems for science, they're actually the very data points that lead to new discoveries about how objects form and evolve. So the unique chemistry of 3IATLAS isn't a paradox, it's a clue. Scientific value of interstellar visitors. So, if 3IATLAS is not alien technology, why is it so important? Well, it's because interstellar comets are windows into other worlds. Each one is a preserved time capsule carrying the precise chemical and physical fingerprints of the environment where it formed. For 3IATLAS, the dominance of carbon dioxide and its trajectory suggest it could be over 7 billion years old, originating from the Milky Way's thick disk, a population of ancient stars that existed long before our sun was born. By studying its isotopic ratios, like the deuterium to hydrogen ratio in its water, scientists can get direct clues about the water in other primordial solar systems, which is a key factor in assessing the potential for life elsewhere. This is more than just a curiosity, it's a preserved fragment of another planetary nursery. Future missions like the ESA's Comet Interceptor are being designed specifically to launch and wait in space, ready to chase down the next interstellar visitor for an even closer look. These objects represent a fundamental shift from studying other solar systems through the faint light of their stars to actually analyzing physical samples. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3IATLAS was the third interstellar object detected, and it's fascinating how different all 3 have been. The first one, Oumuamua, was highly anomalous rocky, appearing to have an extreme 10:1 aspect ratio, and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3IATLAS falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are an outlier. In the end, Comet 3IATLAS wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Simply Science.